Hey guys, I'm Tamir. I guess I should put the deck back up. There we go. That's me. I work at Cockroach. For those of you who don't know, Cockroach is a distributed database. So to kind of, set the tone, we're not like a startup in the sense that we run a service, that we have customers and stuff like that. We're building an open source project that we think is pretty cool, and so that's what I'll be talking about. So just a quick history of what we're up against. So this is kind of some of the stuff that maybe people are familiar with when somebody says the word database. So is everyone familiar with those terms, roughly speaking? People know about SQL databases and NoSQL. So the gist of it is that you have SQL databases that offer conveniences like secondary indexes and transactions, but they don't really scale very well when you need to accommodate for throughput or data set size. And that was sort of the rise of NoSQL was to address that need. But of course, you give away the conveniences to make that happen. So what is Cockroach? It's alpha, so don't go rushing to like start using it right now. We might see some breakage in this talk. It's open source, so it's github.com/cockroachdb/cockroach. We have actually quite a few external contributors. Anyone and everyone is welcome to read the design docs are all in there. Everything's in there. It's really interesting, even if you're not planning on contributing. And yeah, so then there's some special sauce. So the special sauce in Cockroach is it's a scalable SQL database. So we actually implemented the Postgres wire protocol. So if you have a client library that can talk to Postgres, and that's what we'll be using in this demo. So you just point it at Cockroach, and it kind of mostly works. People familiar with transaction isolation levels, roughly, more or less? Yeah, it's one of those things where you're like not really sure which one you should be using, and if you use the wrong one, maybe bad things happen. So serializable in traditional databases like MySQL or Postgres is the highest isolation level, and that's what Cockroach gives you by default. I'll go pretty light on the details here, but you should know that with serializable transactions, you are free of all write anomalies. So that means that if you're running a bank, you won't manifest or destroy money sort of accidentally, which can happen with every isolation level lower than serializable. Cockroach is distributed and replicated, so we use a consensus algorithm called Raft to make sure that we have multiple copies of every bit of data, so that if we lose one of those copies due to hardware failure, something like that, we can sort of continue to make progress. And deployment is actually pretty simple. It's written in Go, so the end result is kind of a single binary that we'll see how that works. But it's pretty handy. You can just like SCP it or rsync it over to some node and run it right there. OK, so let's do. Oh, and I should set the stage and say that if you have questions, I'll be doing a lot of things sort of ad hoc. So by all means, please ask. Don't wait. Just put up your hand and take me off script if you want to. OK, so I have, hopefully that's big enough for everyone to see. I have 3 shells open there. And what I'm going to do is sort of start up my cluster. And the reason I have 3 is because Cockroach likes to replicate all of its data by default to make 3 copies, so that it can tolerate 1 machine failure per slice of data. Does that make sense to everyone? If you, yep?
So, no, it makes sense. So the question really becomes when you use more than 2, the question becomes if there's data inconsistency across the set, right? So what is the control algorithm that says we agree to disagree, and then we'll figure out which one is the correct one to then overwrite to get consistency?
So you need agreement. You need quorum in order to make forward progress. So in a 3-node Raft group, you need 2 of the nodes to agree in order for forward progress, and the 3rd node will blindly accept whatever was agreed if it disagrees. I mean, most of the time it will agree, right? Does that answer your question? OK, cool. All right, so before I get started sort of running the cluster, everything in Cockroach is SSL everywhere. So all the nodes talk to each other over encrypted connections. So that means we need to have some certificates. So like Cockroach that's the binary that I'm going to be using for this whole demo.
Question.
Yep.
F1 is designed for global sharing and global replication. At this point, is Cockroach intended Within a single data center, or have you done?
Well, we haven't really done even cross availability zone stuff, but we will for sure. I mean, I think that cross availability zone is extremely attractive, right? You want to tolerate outages at that scale at least. You certainly could deploy Cockroach at global scale, but remember that when you have a consensus group and you require quorum agreement,
That's why I asked the question.
you're right. That can add quite a lot of latency. And so there's various ways of optimizing algorithms like Raft to allow for quick reads, even if writes may still be quite latent. So that's a complicated answer, but the short answer is that to the extent that F1 is designed to do that, yes, Cockroach is designed to do that. Spanner and F1 are like slightly better equipped because they have atomic clocks and can do things a little bit more efficiently. But yes, I mean they're very similar systems, and so there's no. You have to be careful how you design your topology, but there's no reason why you couldn't do it. Okay.
What order of magnitude, I guess, for a typical read of like round trips between different machines would you need to?
For a read? Right, so RAF doesn't address the read problem. So we actually don't do quorum reads. There's a notion of a reader lease, or a leader lease, I'm sorry, which basically allows you to service all reads from a single node without going to quorum. So you kind of the nodes acquire a lease. I should also say that in Cockroach, all the nodes are symmetrical. So you don't like appoint a leader. That happens dynamically when the cluster is running. But yeah, so some node will acquire the leader lease, and then all the reads can be serviced from that node until it loses its leader lease. And there's also the notion of like reading in the past. And any node can service any reads that predate the current lease, because that data is known quiescent, right? So you can just read.
Does the client have to like say what point in the past they're reading from?
Yep. That was
track that state.
The client can track that. I mean, the client can basically say, I'm going to read 5 seconds in the past because I don't need up to the minute, and speed is more important for me. So yes, you can do that. I don't actually remember if we have or have not yet introduced SQL syntax to use that, but down at the level of key value storage, you certainly can. So it's a matter of plumbing it up through the SQL parser and all this other good stuff. Cool. Any other questions before we move on? OK, cool. So I created a certificate authority. I'm going to create a node certificate. This is like the certificate that the nodes will use to identify themselves. So it's like Cockroach cert create node, and then like a bunch of different host names that are all going to be in the certificate so that it actually validates. And then a client certificate, so my Postgres client thing can also be identified as root. Cool? And then I'm going to make a directory for, so when you start a node, you basically tell it where to store all of its data. So you can see that's cockroach start -- stores equals SSD. That SSD thing, that's just a user provided tag. So I'm just like telling this node that it's running on an SSD. And nodes can use that in various situations where they want, like, you can configure a chunk of data to be stored. Like I need 2 SSD and like 3 spinny disk for redundancy or whatever. You can configure that, and Cockroach will find the right place to put that data. But it's not super important for right now. So I'm just going to start this node. It's going to like bootstrap itself and do all this other stuff. And then I'm going to start a couple more. See this error here is basically it's saying I can't replicate this data enough because there's not enough nodes in my cluster. So when I start the next one, over here, I pass it this like -- join flag because it needs to join the cluster started by the first node. Does that make sense to everyone? Why that's necessary? So this first node is actually functioning just as a seed. It's not the master, it's not the leader, but it is the seed node. If this node dies and I restart it, I can then give it a join argument and point it at some existing node. It's not special, it's just the one that happens to like spawn the cluster. Otherwise you might have like split brain and weird stuff. Cool. And then we'll run a third one. Cool. So that red stuff should probably go away. OK, so any questions so far?
So did you just give it an IP address or something to join?
I gave it a port.
Okay.
So over here, this is the colon port number. That's exploiting a Goism where when you bind to an interface and you don't supply a host name, or rather when you do anything with an address and don't supply a host name, it will use host name. Yeah. Cool. Okay, so I want to open like a new shell over here so I can do some SQL in it. And so Cockroach also ships with a SQL client. And because everything is running on default ports on that leftmost node, I can just do that, and like now I'm connected to it because it's all defaults. And so like basic stuff works. Like I can do a select one. I can like create a. I can do like show databases. We have the system database and like show tables from system. And there's like these are like internal Cockroach tables. And so if I try to like create a table in here, system dot not allowed. Oh yeah. I don't have permission to do that, right? So there is a notion of permissions. It's kind of like the Postgres grammar is kind of a cross between MySQL and Postgres for people who are familiar. So it's like all the administrative stuff tends to be on the MySQL similar end, and and everything else is Postgres-like. So let's make a new database so that we can actually like store some data, and then we can do that so that we don't have to repeat ourselves, and then like create a table. Just 200. Does everyone see that? Yeah. Okay. Yeah. So let's. So I kind of have two directions I could go. I could go and show you guys how you can like explain is something that's pretty interesting in some of these databases that you want to look at. What does it mean when I execute a query? What is the database actually doing? I can show that stuff, or we can go right into transactions and show what that looks like in Cockroach. Any preferences? People want to see transactions? Hands?
Both.
Both. I'll do both. I'm asking about order. But
Curious about to explain and like if there's data locality that you can exploit and see if that's being affected in a.
Okay, yeah. So to answer that, we won't totally see it here, but Cockroach has this notion of ranges, which are basically chunks of data, and each range is a raft group. So there's many of them in the system. Yep.
Before we go there, can we talk a little bit about the data model? Is it traditional SQL? Does it have the kind of extensions that F1 has?
Can you elaborate? Can you explain what you mean by that?
The kind of nested table structure they use?
No, we don't have. What are they called? Yeah, we don't have those yet. We've talked about doing that, and of course, there's benefits to doing that for data locality. For people who, so at the very bottom, Cockroach is. You can think of it as a big stream of key value pairs, and those key value pairs are sorted. So if you have like a key A and a key A and then a null byte, those are going to be right next to each other in the system. And so that's kind of, we designed the SQL encoding such that tables are data local. Okay. So all the data in a table is like next to, if you had like a timestamp, let's assume we were writing an actual column with a timestamp into a table, and that was like your primary key on the table, all that data would be next to each other in the system. No matter what the insertion order was, it would be inserted into the correct place, and data shuffles around to make that work.
Right, I'm sorry. Just to be clear, you're saying the columns are the timestamps next to each other, so it's a column-oriented storage?
No. The rows are next to each other because their primary keys are sequentially. Yeah. So there's going to be like the first key value pair for the row, and then all the subsequent ones, and then the next row that is right next to it. That's what I mean.
Oh, so like it's key value, but like the entire row is a bunch of keys next to each other.
Exactly.
So it's sort of row-oriented in a way.
It is absolutely row-oriented. Yes. That's an explicit decision that we made. But there's no reason why we couldn't implement a column-oriented variant if there was demand for it. It just hasn't. We haven't gotten there yet. It's not high enough on our priority list.
And it's like that, I guess, on all the replicas or whatever you're reading from. Yep. They're just that's the layout.
Correct. Yeah.
The shuffling stuff happens behind the scenes and everything.
Yeah, that's way lower down in terms of the abstraction that it happens at. By the way, there's a blog post about how we map SQL to KV that's I think pretty interesting, and I would encourage everyone to read that if that's if you're interested in that. Okay, so explain stuff real fast. So let's create some data. So we'll just do like 1 1 2 2. So then we can obviously like look at that. And now let's say we want to do an explain. So every database explain looks kind of different, but in Cockroach you have this table that shows you the layering of operations. So here it's a very simple query. It's just going to do a scan over the whole table. That's what you've asked it to do. But if you wanted to do something like, remember that the primary key is an index. So if we did like something like max ID, that actually can exploit the fact that this is an indexed thing, and the system maintains the index for you. So it can just do a scan over the index. And this one here just means I'm going to read exactly one key, because the whole thing is sorted, so I can just go right to the end of that index and grab the maximum. Does that make sense?
Yeah, but could you explain the use of group in the explain?
Group is there because in the general case of running a max, you actually need to do an aggregation, right? So it's there, but it's going to aggregate exactly one row. Does that make sense?
Okay. So
if I did like value here, then that group is actually doing work. Cool. If you're really interested, you can actually do an explain debug. I think this is the syntax. Is it parentheses? And that will actually show you how this maps to like down low KV operations. So this is actually exposing how the SQL data is encoded into the key value storage. So this is sort of two of these keys constitute one row. And again, I don't want to spend too much time on that, but you can kind of look at you can read that blog post, and it goes into great detail about how this is encoded. Cool?
Mind just quickly doing that for the select max ID?
Sure. I don't actually even know what that will output. Oh, there you go. It's going to read it just to one key. Cool. Okay. Transactions. Let's do some of that. So the syntax is familiar. Everyone knows begin and commit and rollback. Those are how you do transactions. So I'm going to run another SQL shell over here, and I'm going to actually use a different node just to demonstrate that like none of this stuff is node local. I can talk to any of the nodes in the system and like things work. So I think it's 15433. Cool. So we can do set database equals demo, select star from KV. Cool. So we can do a begin here, and we can do like an insert into KV values 33. Now before I do that, I'm going to start a transaction over here. Actually, I'm not going to start a transaction. I'm just going to do select. So I'm going to pause for a second and just talk about how transactions behave in Cockroach rather than how they work, really. Cockroach is an optimistic concurrency system, so there are no locks. So in Postgres, if you did this, if you ran this insert and then did that select, and you were running with serializable isolation, the select would block until this transaction either committed or rolled back, because you can't be certain of whether that thing is, in one state or the other. Because Cockroach is a lockless system, what will actually happen is that transaction on the right will do its darndest to abort this guy on the left. And because we're running in this SQL shell, we have this mechanism where we automatically wrap that one statement into a transaction, and that transaction will get retried. So basically, what I'm going to do is I'm going to run that insert but not commit, and then do that select. And what we'll see is that eventually that select will go through and not see the 3.3 written. And then when I try to commit this guy over here on the left, it will fail. Does that make sense to everyone why that's the expected outcome? Yeah?
But it would be surprising from an application development point of view.
Right, and so you have to kind of adjust your expectations. Basically, the contract with transactions in Cockroach, the contract with many other lock-based systems and SQL transactions is that they may block or they may even deadlock, but like if they do, then something has gone wrong. Whereas with Cockroach, aborts are expected, and you should just retry. So if you have like is anyone like a Rails developer here? Maybe, or a system like any language that has like the notion of a closure, like a function that you can pass around. Yeah. You can imagine you could have the API exposed is that you pass a function that function gets executed inside of the transaction. And if we were writing the client library for Cockroach, we would make that thing retry until it succeeds, because it should be written in such a way that it's safe to execute that closure multiple times. So like don't send emails, for example, inside that closure. Yeah. Yeah, does that make sense to everyone? Okay, So let's see and hope that it actually works like I described. So that's blocking because it's trying to abort this guy, and there's a random priority thing going on. And there's an exponential backoff. So each time that it fails to abort this guy, it's waiting longer and longer until it next tries to abort it. So given enough time, this will actually, I mean, it should any moment succeed. I might actually be able to, yeah, there it goes. So now when I commit, I get this error that says, like, you got aborted, here's the whole transaction record dump that you were in the middle of doing. And of course, if I read from KV, there's nothing in there, or that value's not in there.
Is
Cool.
that delay tunable at all? Or do you intend for it to be?
It is tunable. The intention is, we probably should make, I mean, the intention is that transactions in the real world are never going to be this slow. Like, I'm a human being, and most of the time computers are doing this. In fact, I'm actually running a modified build here where normally this transaction would time out after 10 seconds of inactivity, because there's a heartbeat going on that keeps the transaction from being, like, marked as garbage. So I've jacked it up to 5 minutes so that I can do this demo without, like, typing super fast the whole time. So it's not tunable, but I think we are, like, originally we had this KV API, and that's where this exponential backoff came in. We're probably just going to throw that away and just retry as hard as we can until one happens or the other happens. Okay, what else? We can do, well, we did a read-write. We could do a write-write. Maybe we could do like an increment operation in two transactions and show this is write skew. Everyone, does it? Yeah.
How do the locks work? Was that on the table? Was it a global lock on the database? Or
There are no locks.
Or of the, not real lock, but the transaction, what does it?
What does it do? How does it?
Is there only one transaction allowed at a time? The whole cluster? Or?
No. There is no limit to how many transactions. So what happens, the way the transactions work is the first time you try to write something inside of a transaction, you write something called the write intent, which is kind of like here's the value that is not yet live. And also in another part of the key space, you write a transaction record, which contains a bunch of metadata about this transaction, like whether it's committed or not. And then when everything's done and you're ready to commit, you go to that transaction record and you flip the state from pending to committed. And then you kind of do your best to clean up all these intents. But it doesn't really matter if you clean them up or not, because the next time that a reader shows up and sees this intent that's like unresolved, it's going to go look at that transaction record, and it's going to see, oh, this thing's already committed. So it will just turn the intent into a proper value and be able to read it. Conversely, if there's a conflict, like this transaction is not committed, it's still in flight and it's trying to abort it, it will go to the transaction record and flip it from pending to aborted. And that's how this guy learns that he's aborted, right? Like, notice I only learned that I was aborted when I tried to commit, not before.
So the one on the right, it was looking at that table for that metadata. What was it looking for? It's just running to this table.
I'm sorry?
My point is, if there were two tables and one on the right is trying to access a different table, would it block?
No. Those are operating on totally non-overlapping parts of the key space. In fact, I can show you that if you.
Is the grain of those things the table?
Sorry.
I'm just trying to figure out like what contends with what.
Well, when you try to read the whole table, you're going to contend with everything that's operating on that table.
So it's like a row level virtual lock.
It's actually even finer grained than that. It's a cell level virtual lock, I would say, because you can.
Each individual column and field.
Yeah, each individual grid cell you can.
Okay, so if you did that same select, but it didn't select the same column you were inserting in, then it would be no conflict.
Let's try it. I think so.
So can you do like a select for update on a row?
You can't do select for update. I mean, that by definition requires a lock.
Are you trying to simulate locks here?
You could. I mean, if you could do it.
You're trying to make it transparent.
You actually don't need to. You get the same thing from serializable isolation, right? If you have conflicting writes, then is that true? If you do a select for update and you actually don't update it, no. I mean, you can emulate it, but we haven't implemented that. But you could basically write like a ghost intent that didn't have any value associated with it. It's that answer your question?
Well, I mean, sometimes you want to do select for update, even though you're not going to write to it, just
Right.
use the database logging mechanism.
Right, and yeah, so what I'm saying is it's possible to emulate that in Cockroach. It won't actually be a lock. It'll just tell you that someone else got there first and you got to try again.
Yeah.
But it's possible to emulate it. We just haven't implemented that yet. Does that make sense? If there's sufficient interest, we will, yeah. Did you have a question before?
I think the comment about the granularity of those locks, where the optimistic locking is.
Well, so it's at the level of a single key down in KV.
Yeah.
So right now it happens to be modeled such that each of these cells is a separate key.
Yeah. So when you did the insert, you inserted into
both.
That's just like 2 cells right there. All right. So basically 2 cells are kind of.
Yeah. So I mean, so let's just do that thing, right? Yeah. We can just do like a non-conflicting case. So we can do what is it? Update KV set ID equals ID. Can I do that? Probably can't do that. I could do value. And then over here. So can everyone see that and agree that those should not conflict?
They're both on value, right?
Pardon?
Yes.
They're both on value?
Yeah, they're both on value. So they're different rows.
Oh, different rows. Okay.
Yeah, I don't think actually you can update the primary key of a row.
Okay. Yep, makes sense.
So yeah, so I mean, looks like those both went through and both committed and they're updated. So there's no contention there. What else can we show you? Do people know what write skew is? Like, what happens if you ran these transactions at a lower isolation level? Well, it turns out you wouldn't have the same guarantee. So if I actually did this in a way that did conflict, like let's say I have these 2 concurrent writers and they're both trying to increment this thing, like some kind of counter field, then this guy, basically that guy on the right is actually going to do a read, right, in order to set that new value. So these are going to conflict, right? Everyone agrees with that? So if I'm going to do this, I see the update here, right? I've incremented this guy by 1. If I do this, I get, oh, this is like a weird error. But yeah, I'm aborted. And maybe also aborted here.
Last one wins, but
last one wins because, well, in this case, I don't actually think it's going to be last one wins. Because there's no retry happening here. It's a coin flip.
right, because you didn't retry, then you just lost.
Right.
Yeah, that's why you have to retry.
Right, because you keep on losing. You keep retrying it while you're losing until you eventually win that coin flip. Of course, that is actually tunable. So you could do like a begin transaction, priority high, and this will give you a better chance of like not getting aborted by somebody else. And over here, you could do begin transaction priority low. You get the idea. It's all probabilistic, so it still could happen, but it becomes something like 10,000 times less likely. Okay. Isolation level. People know what snapshot isolation is? So what I just did there, where these 2 guys were trying to increment and conflicted with each other, that didn't go through because of serializability. But if I did begin transaction, isolation level, snapshot, and over here.
So like in VCC times?
Yeah, exactly. So basically,
For reads there, right?
well, not quite. The commit is going to happen, like one guy is going to commit before the other guy tries to write. So what? Let me just show you that. So I'll do the same. Where's my cursor? The same query over here, and then I'll do that select so we can see what's going on. So remember, we rolled back earlier, so that's pardon.
There's an implicit transaction going on right now.
There's an explicit one going on. I didn't run this commit. Sorry, that was like this shell is kind of junked up. You can do show transaction isolation level or priority. What do we want? Isolation level. to show that we are actually in a transaction. Okay.
Okay.
So over here, I'm in a transaction, and I can do a select star from KB, and I don't see that intent. So I'm actually just I'm reading inconsistent, basically. And so now I can sort of go and commit this thing. Do I want to write it first? I think I want to write it first. So I could do update. Oops. Oh. And so now I'm going to commit that. Oh, so the write-write conflict still kills me. Let me try that one more time. Let's do that.
Yeah, that makes sense.
Oh, it's still there.
Yeah, so your last one, the last one won in this case. You said, okay, I'm going to do this update.
Well, you know what? I didn't actually try to commit it, but you're probably right. It probably did win over on the right.
Yeah, because it was the most recent one. So you said, oh, okay, I'm going to go abort this other transaction.
Right. Yeah,
Right
so how do you demonstrate Nathan, do you remember? If you committed it first, you would then read the right thing. I mean, I feel like that should have worked. This is like a bug that we never got to the bottom of. But the intended behavior is that only one of those, or both of those increments would sort of independently succeed, but you would see that the key had only incremented by 1 because they both wrote the value like whatever it was at the beginning plus 1. Does that make sense?
No, because on the right, I'm confused because I don't understand how that. I get MVCC from a reading perspective because it's easy to read like whatever this past snapshot is from a write perspective. Like all the normal databases are with, like they have to go on the route of exclusive locks and everything for writing, and that's when you have all this contention, especially in the increment situation.
Yeah. So this is what I'm actually showing you here is like surprising and sort of dangerous behavior, but that is something that you opt into by using snapshot isolation. So snapshot isolation exists in Cockroach only as a performance concern. So if you know what you're doing and you're okay with reading it consistently, you can use it.
Is the semantics for the right side of the house, you're updating an old snapshot, and then the system's going to figure out a way to reconcile this thing?
The system doesn't reconcile anything. It actually does the wrong thing.
Gotcha.
So you have like 2 incrementers that are both like they both come in and they read the old value that says 2, and the other, one guy says, okay, I'm going to set that to 3 now, and the other guy goes, oh yeah, I'm going to set that to 3, and then they both commit and it's set to 3 now because that's right skew.
Well, in this one, it was like the last one had set it to 3, whichever the last one was, because the other one got aborted or something. Is that
right? Well, I mean, again, probabilistic. So either one of them could have been aborted. One of them would be able to proceed, and one of them would not.
So at the level of the key value store, each of these transactions is written to value 3 associated with its transaction ID.
Yeah.
And when we get to the point of a commit, one of those commits will succeed.
Yeah. But if you did like, imagine a transaction where one guy reads and then the other guy writes, or he reads and then immediately places his write intent, and then the other guy reads and like in memory holds this thing and increments it in memory, and then this guy commits, and then this guy's going to like write another one. In snapshot, that would work. In serializable, it won't because the timestamps of those 2 transactions are in conflict.
Right. But in snapshot, in effect, both sides see the state of the database when their transaction started, plus their own changes.
Correct. Yeah. So that's why that's why it's not the default, but it can be more performant. Cool. So that's pretty much what I have as far as like the script. Anybody have anything they want to like explore or ask about more detail on?
So I guess I'm curious about like how the distribution works. I know a little bit about Raft, and it sounds really awesome. But it sounds like you guys have essentially made the decision of consistency over availability. So if you have like a network partition state, that it can't, so if you had like 3 nodes and one of them gets cut off, it's going to say, oh, sorry, I'm not going to service any of your requests?
That one node absolutely will not service anything. Yeah, that node will. In fact, let's do that. Why don't we actually simulate that situation? Let's like kill one of these nodes. So like this guy on the left, I just shut it down. And so if I like try to do something over here, oh, that node has gone away. So over here, though, I can still do
Is this talking to the two nodes that are left?
one of them, yeah.
Yeah.
Roll back.
Roll black. This is like this regression. This should eventually work. We have like there's some regression where Raft like gets slow or something gets slow when one of the nodes is down. But there it goes. It does actually work, and you can even like insert into KV values.
You selected a new leader and that kind of thing.
Yeah, I mean that is expected by there's more problems than that. It actually is slow on. That should only happen once. I'm pretty sure this operation is going to be slow also, and that's something different. Yeah, why is that slow? I like discovered this yesterday, so.
If you had a much larger cluster and there was a network partition like splitting it in half, and you had like 5 nodes on one side and like 7 nodes on the other side.
Yeah, that's a good question. So actually, hang on. You had a question before?
Yeah, I was wondering, did you do anything unique with foreign keys?
We don't currently support foreign keys. We will probably eventually support them, but it basically boils down to like doing a whole bunch more reading when you write something. So there's no reason why we can't implement it. We just haven't yet. As far as your question about data distribution, remember that the Cockroach cluster is not one Raft group. There's many Raft groups, and so even if you have like 100, 1,000 machines, the size of an individual Raft group is still 3 or whatever you've configured it to be. So
just for where it replicates the data?
That particular chunk of data. That chunk is called a range in Cockroach, and it's about 32 megabytes usually.
Oh, wow.
So that's the unit of data can move from one node to another in 32 megabyte chunks. And that size was chosen because of considerations of how much data you want to be able to address in the system and how many ranges, But basically, the lower it is, the more granular you're able to move the data, more right.
Do you have that diagram in there?
I do have that diagram. Somebody want to see the diagram? Diagram good? Yeah, so I mean, you have these key ranges, and remember I said that everything's like a sorted map. This is actually wrong. It contains up to 64 megabytes. But they will split and merge and move. So if like node 3 just like falls off the planet, and then a new node comes in, one of the nodes 1 and 2 will notice that this range is under-replicated and will basically send a snapshot over to this new node to sort of heal the cluster.
Following this right, that one consequence of having these different groups is if you have a partition, you can have different colors in your example, where the majority of one color is on one side, the majority of another color is on the other side.
Yep, that can absolutely happen. And the consequence there will be that one side will be able to service requests on a portion of the key range, and the other side will be able to service requests on another portion. But none of that is verboten. You can do that safely because once the cluster heals, there are no inconsistencies. Once the partition heals.
As long as you don't have operations, transactions that need to span the.
Well, those will fail.
Yeah.
Yeah, they'll just fail. But they won't like silently like throw data away. They'll just fail.
If you tried to read from the other half of the brain, it would fail because the data isn't there, it's in the other half.
Right.
So you wouldn't get any inconsistent data at this point.
Yeah.
Oh, but certain operations would become impossible.
Right, that's
Right,
the whole
it's not as-
visibility over consistency.
Right, but imagine if you're running a single Postgres database and you have a network partition between all your app servers and your Postgres database. You've just in one shot lost 100% availability.
Yeah.
Okay, but you've got a new kind of failure case here, where certain kinds of transactions.
I would say that's an old kind of failure case, and in fact, in Cockroach, it becomes a degradation, not a failure. In Postgres, it's a failure. It's zero. It's all or nothing. But in Cockroach, you may have access to some, right?
Whatever's in the other
Well,
partition is what you
okay.
can't get to.
What I'm saying though is that you don't have to look at your applications to see what are the circumstances under which they can fail. Some operations could remain active under certain circumstances, and others won't.
Yes, that's true. Yeah.
So, Tamir, can you coerce the locality of key ranges, like given this kind of failure mode?
Meaning, can you control the locality of them? Like, I want this data and this data to be together. Yes, you can. So the decision of whether to split a range or not is governed by a couple of different things. One of them is like the size. If it gets too big, you want to split it. But another one is what we call zone configs. So you can basically artificially say, starting from this key to that, I want to split at this key. And in fact, we do that. Every time you create a SQL table, that is there's definitely a range boundary there. So tables are already data local. Now, if you wanted to have tables that are next to each other in the key space, you could create a zone config that pins them together. Actually, today, if you wanted to do that, you would basically, today it's pretty coarse. Today you would basically just create them one after the other. Those two would be next to each other. Down the road, you would do something like what F1 does, where you can actually have embedded tables. So you embed a table into another. It's kind of a fringe. I mean, it's
syntax that lets you specify it.
Right. Mm-hmm. Yeah. Yes.
So in regards to like the self-healing mechanisms and like the availability kind of management, do you guys have anything built in out of the box, like batteries included?
Everything's batteries included. I mean,
but like as far as like it seems like when you have the node, it's kind of irrelevant because everything gets localized, right?
I'm not sure what you mean.
The blobs shift around, therefore the nodes are kind of irrelevant.
And so the question is,
how does it self-heal?
You imagine that you have a cluster of 20 nodes, not 3, right? And so does that already answer your question? Yeah. So the point is you run a cluster that's going to be bigger so that if a node fails, there is another node available to take that replica.
There are warnings, I would presume, if you start to have more data than your nodes will support?
There's probably some cases where it'll just like die in like bad ways right now. But we're like I said at the beginning, we're still in alpha, so part of our own evaluation process for maturity is the level of testing that we're doing. So we're doing like bigger and bigger clusters, running them for longer and stressing them in different ways. It probably still doesn't do it probably still does something crazy in terms of it'll run up the disk all the way to full, where you probably never ever want to do that. Like it's better to just let the node just terminate when it reaches some threshold. But yeah, I mean, the safeguards will be there when this is production ready.
Can you explain a little bit how the physical data gets laid out with respect to this data in such and such table on such and such nodes, given like a 20-node cluster or a 3-node cluster or something? Like, how does that map out? If I say create a table and I start a bunch of inserts, is there any way for me to understand sort of where that data is?
In terms of what node is it on?
Yeah, like which nodes and which like sort of key ranges, like how are those things connected up?
In terms of the key ranges, we saw that a little bit in the debug output. You could see like how a SQL
file system sort of thing.
A file system sort of thing. I mean, you can think of it as a file system, right? I mean, if I did that, explain sort of way back. Oh, here it is. Like that. Shit. What's the other one? This node is dead. I'm going to bring that node back because I don't want to wait forever. You can think of that as a file system. I mean, that leftmost slash is the root, right? I mean, that's...
So that's the root relative to what? Not the local file system on this one node, right?
It's not anything to do with the file system on any given node.
Okay.
This is
the overall key space managed by the entire cluster.
Correct. Yeah.
Okay.
And those are not real slashes, though they are literal. Well, actually, that whole thing is pretty printed. Pardon me?
They're obviously slash characters, but yeah.
Those are not slash characters. We pretty print those keys on disk. Like you want to have those keys be quite compact because you write the key. Right. So this is pretty printing the key representation. It doesn't look like that, sure, but the key is just a string. Yeah. But it's not that string.
Yeah. No, that makes sense.
Okay.
So this is a representation of like the whole cluster, not just what's happening on whatever node or something along those lines.
There's almost nothing that you could do in Cockroach that operates on the scope of a node. Everything is cluster because the node is not really the unit of abstraction that is useful.
But ultimately, it does get stored on nodes.
Okay, yeah.
So like, how does
that work? So at the very bottom, it's RocksDB, which is an LSM-based sort of storage, open source storage engine. It's like a whole topic in itself, but basically it maintains the invariant that keys are stored in order. So it gives you like efficient sequential scans over keys. And so when you insert a key into it, it will like rebalance the thing and make sure that you can scan sequentially over it. So that's at the level of a single.
It manages that on disk for you.
That's on disk, yeah. So when I start these nodes and I give them like some path argument over here, stores, and then temp data 0 over here.
Okay.
This is this is a literal folder on my disk that contains all of this data, and that's all RocksDB. Yes. So you could run like a single node with multiple stores,
right.
Which like let's say you have a bunch of hard drives, so you want like a single Cockroach running, but using many disks. So you could do that with like some syntax to that parameter, which I've personally never used. Yeah, and so a level above that, you have this node that you're talking to, right? I mean, you're going to say, I want to look at some key.
To right now, at the moment.
Yes, yes. That node is said to be your gateway. So you say to that node, like, hey, I want to read some key, and that node may not even contain that key. That key may be in Japan, and the node is in, Alaska or something.
It's going to go get it.
Well, it doesn't just know, right? I mean, that would be where it's not magic, right? So there's basically a two-level hierarchy of how to find a given key. So remember at the very beginning when I started one of those nodes and I said that's the seed node, and it's like that one is like briefly special while the cluster gets going. The reason that is special is because that node creates the first range descriptor, and the first range descriptor is actually a special thing in the system, and that one never always contains what we call the meta one. This is going to get really fun, interesting though. To do it in Handwave. I wish I had like a whiteboard or something. But it contains all the meta 1 records. So what that means is that the number of keys that can be addressed by the system is limited to how many meta 1 records that first range can hold. And it turns out to be something like 4 exabytes or something that the system can address. And the reason it's 4 exabytes is because the first range is 64 megs. Each record is like some rough estimatable size, and then there's a meta 2, which can be quite a lot bigger, and that gives you.
There's 2 levels of indirection and so forth.
That's right. So you could add like a 3rd level of indirection and have like astronomical addressing power, but it would be a 3rd level of indirection on every lookup. So what happens when you ask for something, the gateway goes to the first range, reads that meta 1 record, figures out where the meta 2 record is for the key that you're after, then reads the meta 2 record, and that will tell it which nodes contain this key range. And finally, we'll RPC to that node and get the data back for you.
Okay, cool.
Yeah, and so the same thing happens on a write, right? That's what maintains the sorted invariant during writes, is that it will figure out where this write needs to go, and then way down at the level of the disk, RocksDB handles that.
Okay.
That makes sense to everyone? Sorry, I want to make sure everyone's with us. Yes?
Okay, so let me expand on this question there. So if I have just three nodes with our replication factor of 3, every write is really going to go to each of the other 2 nodes, right? Correct.
Well, it will go to the range leader. Yes.
Okay, but it'll end up on all 3 nodes because it's R3
That's right.
and there's only 3 nodes.
That's right.
Okay, so that's kind of not interesting. If I insert a huge range of keys, they're all going to go everywhere anyway.
Yes.
To every node anyway.
That's right.
Okay, so let me go to 6 nodes. So I have, so that
half is on one.
Yeah.
Yeah.
Right. So every node will only have half the data in theory.
Mm-hmm.
So now let's suppose so where do the keys go? Back to this question. If let's suppose I insert A, just lexicographic order, AAA on this node, and on some other node I insert ZZZ. Where do in those 6 nodes do these two keys go if there's only these 2 keys?
They will go in the same range because, and so basically you're going to have 3 nodes that have some data and 3 nodes that have 0 data.
Okay.
Because
and until I get to 64 megs.
That's right.
Okay. Okay.
Yeah. Yeah. Or if you've inserted a zone config that says split at key J, that will, as soon as you write the Z, boom, it's going to split and create 2 ranges because there's a configuration that says, there's a rule that you've created, okay. These 2 shall not be on the same range.
So now so it gets to that point and it splits. And now, where does the second range go to? I had the 6 nodes. So
it may go nowhere.
It may stay on the first 3?
Yep.
Or it might go to the other 3?
It might stay on one of the first 3 and one of them will, like 2 of the replicas will move. It's really like it's actually probabilistic whether it will move or not, but it also is something that, like you can spend endless effort in tuning these heuristics, right? Like, oh, how much CPU is this node expending? How much network I/O is it doing? Do I want to like rebalance the read traffic? Do I have enough disk space? Am I on the same rack? Do I want to be rack local? Am I an SSD? Do I need a hard drive? There's like myriad things that you can
if you do those
factor in.
Kind of 64K worth of data, and you do that, say 100 times, enough to get so it's statistically it's
likely to move, yeah.
So over time, it would pretty much be 50-50?
In terms of, right now, I think...
Two sets of three? It's
well,
not really two sets of three.
Right now, the only criteria that we take into account is disk space. So yes, it will try to have uniform disk usage across the cluster. In the future, though, you can do much more sophisticated stuff, memory usage or network
I/O.
I/O.
Balance automatically is the point.
That's right. There's no human involvement here, except for to the extent that you create these zone configs that can dictate that some data lives on SSDs or needs like one SSD and two spinny disk or whatever.
Also, probably have time for 1 or 2 more questions, and then I presume you'll be hanging out.
Yes, I'll be around.
Awesome.
Anybody else? Yeah.
Question about, so you mentioned at the beginning of the talk that like secondary instances are something that's nice to have in SQL databases. Is that something that you guys are supporting now, or like?
Secondary indexes?
Yeah.
Oh, yes. Good question. I mean, don't forget that the primary key, which we saw earlier, is itself a secondary index. But if your question is, can I do this on KV, what do I have, value? Sure. And then
Is that also distributed, or?
Yes.
That's in the blog post.
Yeah, we have a blog. There's a blog post on how we do that thing on the right, the mapping of SQL tables to key values pairs. But this is also remember, this is a distributed system. So like in Postgres, for example, or actually in MySQL, for example, this will hold a table lock while it's writing that index. But we can't do that. So we have an asynchronous process that is basically, it's using, the schema in the system is actually eventually consistent, not strongly consistent. It's a complicated enough topic that if you're interested in, I would suggest reading the blog post and maybe the F1 paper, because they also talk about that. Cool? Yes?
Were you a Google guy? Or?
No.
Okay. So you might not know the answer. Why is Spanner called Spanner?
I have no idea. Probably because it's a tool, like a wrench spanner. Useful tool.
Where are you on your roadmap?
Where are we on our roadmap? We are approaching beta. We're trying to wrap up beta for maybe this quarter. And the guarantee there will be that we will stop breaking the on-disk format, so that if you try to do a version upgrade, you can bring down a node and bring it back up, and the data, it will be able to read the data. The thing that we're reserving is we may still break the wire format, so you'll have to bring down the whole cluster and then like upgrade everything and bring it all back up, because they won't talk the same protocol. But that will be the beta guarantee. Yes?
What's your ultimate business model for the company?
We're not really sure yet. We've talked about a lot of different things. I mean, we think that something like what Mongo's doing, for instance, is possible, where we can the main product is always going to be open source, but we may have extensions on top of it that aren't. Mongo, for instance, sells a graphical user interface thing that is not part of the open source distribution. There are lots of other opportunities for value adds that we can provide, given given some of the properties of the system. For example, we can do archiving, like eternal archiving, so that you can basically do point-in-time queries on historical data indefinitely. That's something that wouldn't be included in like the open source thing, because it adds a bit of complexity. But that, that's just another example. But I think that with adoption, the opportunity to monetize will come. And our investors think so too, I guess. Cool? Thanks, guys.